I think we start. What do you think? I think it's 2:02. I think it's time to start.
It is time.
Yeah. So hi Zoomers. Hi Rimmers. Happy Garbage Day. Happy we're almost done with the semester day. Like doesn't feel that way. It's coming up, folks. So homework 4 was due yesterday. I updated grades this morning, and in so doing, I realized that I can't do math. So I have a spreadsheet that I made for all the points that things are worth, and the spreadsheet this morning said it should be 79 points for homework across the semester. And then I did the math to realize that I'm 2 points short. And I had thought homework 1 should be worth 14, but I only made it worth 12. So I'm giving everybody 2 points, okay? So the math works. That was what I intended. A lot of folks got a perfect score on homework 1, so I'm just going to make an inference that if I had given you a few more questions, you would have done fine on those. So everybody gets 2 points. Homework 5, the TAs have, that will be open probably by Thursday. Also shooting for Thursday, FA6, which is due right after break, and FA7 will be launched probably this Monday as well. So 2 quizzes and 1 homework left, and that's it. So we have interaction terms. The example we're going to talk through today has the models that will be used as templates for completing homework 5. So that means that if you want to work ahead and get stuff done, be my guest. If you want to put it off as long as possible, go for that instead. And then the last day of class is typically sort of a, like, not want to say throwaway day, but sometimes it becomes a little sort of loosey-goosey. Please come the last day if you can, or at least watch the recording, because I haven't talked at all this semester about all of the assumptions that we have to make for these models' results to be believable. I haven't talked about that at all. And that's normally like right away. The reason I chose to do it this way is because I find it dissatisfying to be like, well, this has to be true or else. And then you're like, or else what? And you're sort of left hanging with what you should do instead. So I wanted to build a more focused lecture around what are the assumptions, but more importantly, what happens next if they aren't plausible? Where do you go from there? And I had intended that to be also a segue to help people get into the advanced classes, not knowing when those would return. I can't really do that this time, but if you have the opportunity to take that coursework elsewhere on campus or to read about things on your own, that would still be a benefit to you. So that's what I have planned the last day. So any homework 4 questions?
Did everybody get it in?
No. Not everybody got homework 4 in. No, that's a pipe dream on a class this large.
The reason I'm asking is because it did take place in the other class.
Yes. Yes, the last homework, my other class, all 9 of them turned it in on time, and we got to talk about it as a group. And that happens about once every 5 years, give or take. Not everyone has completed homework 4, but the scores are relatively good. Quite a few folks had perfect scores. So I was pleased to see that. It should not be difficult, it should just be tedious. That's what my intent is. She's like, yep. But if you
I haven't done it yet.
Okay, it's fine. It's not it's meant to be a review. That's fine. Late work is accepted until Wednesday of finals week. And so turn in everything by then, please. I will turn in grades based on whatever you have, and we'll go from there. My intent is to turn in grades before all the fun begins and the chaos of moving begins. So, yeah, good times. Any questions on upcoming due dates, requirements, otherwise? So we started talking about interaction terms. The idea of moderation, that's the topic, the last topic. The idea that the effect of one variable on an outcome depends on where you are on other variables in the problem. Different slopes for different folks, as one might say. And Michael wanted to make a point about this. He's in the class I teach before this, which is on clustered multi-level models. And today we talked about interaction terms. And you wanted to say?
Well, I just want to mention that interactions don't go away. Do they actually become more complicated and more needed? So not only in that class you have to worry about interactions occurring, you have to worry about which level they are occurring. You have to worry about if you are crossing levels with your interactions. And you also sometimes need to implement them so you do not have conflated slopes or effects interpreted. And so this is a very good baseline understanding to be able to do that sort of work.
Okay, yes, thank you. Zoomers, did you hear that? I can reiterate if not. Yeah, basically this stuff is going to keep showing up. If you take more courses, it's going to, so just if you can understand it in the context of this type of model, those same exact concepts, routines, and processes carry forward into more complex models. It's just then they become more complex, because that's just life. But I can try to boil it down as much as possible. To me, there's only two kinds of interactions. And within that, direction. And the job of an interaction term is to take the slope of the predictor by itself and make it either more positive or more negative if it's a strengthening effect, or less positive or less negative if it is a weakening effect. So we had walked through this slide. We did this twice. Rather than do this one, I wanted to return back to the stories. Can we do stories? Okay, so Zoomers, there's a lot more of you today than there are roomers. Okay, there's 3 roomers and a TA here, and there's lots of Zoomers. So if you want to participate by talking or typing, that would be lovely, because the 3 people here are like, oh my God, I have to answer all the questions today. I can also make the TA answer questions. I do that too sometimes. But just to reiterate what we were doing last time, I'm giving you story problems that are answerable via interaction terms, and we're trying to anticipate the direction of the main effect slopes and the interactions that would be consistent with the hypotheses given in the story. So the one we did last time was the idea that camera use on Zoom is related to better grades, but less so in larger classes. So for that to be true, we have to know what the reference level, what 0 means for each of my predictors to interpret the main effects. But let's say that if this is the slope of camera use in medium-sized classes, we think it should be positive. Camera use is related to grades. The effective class size we thought should be negative in people who don't use their cameras. And for camera use to matter less as class size increases would be consistent with a positive main effect and a negative interaction term. Less positive means that camera use would matter less as size increases. Okay, want to do the next one? So the outcome is health. This is a treatment hypothesis that people receiving a new treatment decline less over time than people receiving an older treatment. So what are the variables in the problem? I'll start off with my intercept because we always need one of those. At least one. There should be 2 variables in my problem. What are they?
Binary for which treatment?
Treatment. Very good, Zoomers. Thank you. What's the other one? It's kind of implicit. Yeah, time. Very good, Zoomers. Thank you for playing along. Yeah, decline less over time. Time has to be a predictor. So that already means that this example would not be appropriate for this class. It's a longitudinal example. I don't care, because the idea of the interaction term here is the same regardless of what your model for the variance looks like. So these are the 2 parts of the story. Is this model sufficient to answer the question, or do we need to add some stuff?
You need stuff to account for the less over time.
Yeah, I need the less. So what I have is treatment and time, but I don't have less over time. So that would be my interaction. So now the patterns. Traditionally, in longitudinal analyses, particularly for treatment studies like this, time is censored so that your baseline observation before they start doing anything to you is time 0. And then they track how long it's been since you've been starting treatment. And traditionally, treatment would be a binary predictor in which 0 is the control group for the standard treatment and 1 would be a difference in treatment. So then this should be positive or negative. Kind of a trick question. What do I have to know to anticipate this?
What did treatment do?
Yeah, when is this the treatment effect for? Because this is the treatment effect specifically when the interacting predictor is 0. So when is time 0? We just said? Beginning.
Before.
Yeah, at the start. So do you think that the treatment and control group should be different at the start? Yeah, at the beginning, very good. Let me put it this way. If you're randomly assigning people to treatment groups so you can make some kind of causal inference about your treatment, do you want them to be different at the start or the same? Yeah, we want them to be the same in this case. We hope there is no treatment effect at the beginning because that means random assignment did not work. So I'm going to put 0 there. How about time? This is also conditional on the interaction term being zeroed out, and that happens when treatment is 0. So if I'm talking about the control group, what's going to happen to them?
Bad.
They're bad. They're declining, negative. Now what if the treatment group declines less? Should this coefficient be positive or negative? Got to vote for positive. More votes for positive. The positives have it, yeah. This is an example of a less negative hypothesis. Health goes down. We're going to try to stop health from going down more than it needs to. We call that healthy aging. How about this one? Stronger tendencies towards forgiveness relates, that's not English, relate to a reduced impact of stress on disease severity. Need my intercept? What are my variables? Say forgiveness. I got stress in the story. And I got their interaction. It's going to be an interaction. And there's no ness in the story. There. Let's say that forgiveness and stress are both mean-centered. So 0 is like an average level of either one. Do you think people who are more forgiving have lower disease severity or higher disease severity? Forgiveness is good for you, right? I'm going to say they have lower disease severity. This is a friend of mine's dissertation, by the way. That's where this story came from. Is stress good for you or bad for you? Stress is bad for you, but the outcome is severity. So which way does my slope go? It's positive, yeah. So this is an example of where wording choice is going to matter. It's like the effect of stress, like this is the positive effect of stress, but it's not a good thing. It's a positive slope. That means higher stress relates to higher severity. Now, if forgiveness reduces the effect of stress, what should happen to my coefficient? Okay, got 2 votes for negative. Another vote for negative, yeah. So stress has a positive slope, meaning more stress is more severity. That happens less in people who are at higher forgiveness. Okay, how are we doing, folks? Last one. Diminishing returns is an idea. Spending more time rehearsing stops improving performance and might even hurt at some point. Performance is my outcome. What are my variables?
Time.
Yeah, Rehearsal time, we'll say. And performance is my outcome. Yeah, I don't have another variable in my story. So why do you think this made it into my interaction example spreadsheet? Yeah, Michael's making signs in the back here.
Think rainbow.
Like, helps, maybe doesn't help anymore, maybe makes it worse, Cliff. How do I make this? Quadratic. Why did I put this example in my interaction spreadsheet? Because quadratics are interaction terms, and they're more positive, less positive, more negative, or less negative. They take the line, they speed it up, or they slow it down. Yeah. Now, if we're right, which way does it go?
That's positive.
Yeah, I think if time is centered at the beginning, like no rehearsal time would be the 0, which is possible, then this would be less positive over time, gradually hooking it into negative territory. Yep. So these are just some examples out in the wild from research I've either made up or been asked about or have helped with. Moderation terms and interaction terms are everywhere. So these are just 2-way versions. There's also potentially 3-way versions. Do you want to see an example? Like maybe one that will help you finish your homework for this class? Pragmatically. I didn't have that open somehow. I know.
You're not perfect.
I'm imperfect. It continues. There we are. This is example 5. So you've seen the first model in this before, but I wanted to refer back to it so that we could make comparisons between the first model and what is new. So these are the old people data that we use for example 4B. I have 550 fictitious older adults. We're predicting their level of cognition from their age, their grip strength, binary sex with men as the reference, and then 3 category dementia diagnosis with the never gonna get it group as the reference as well. Ding, ding. So the code to do all of these things is not different than what you've seen before. I'm happy to answer any questions about that, but otherwise I don't need to belabor the point. So we have examples of continuous predictors that are being centered at constants, and an example of categorical dementia group that has contrast being created to differentiate the other groups from the reference. So here's what I'm calling a main effects only model. This is the same model at the end of 4B, but I didn't use those words. So this analysis would be used to answer a research question, something like, how does age in years, grip strength in pounds per square inch, binary sex, and 3-group dementia each uniquely predict cognition? So what does this word imply? Uniquely. Can you give me some synonyms?
On its own.
I didn't hear you, I'm sorry.
I take it back.
You take it back? Okay. You can phone a friend if you want. What does unique mean to me? Give me some synonyms is the question. How would other people use this?
Separate or like not overlapping.
Not overlapping, independent, good Zoomers. Folks would also say after controlling for, holding constant, adjusting for. These words all mean the same thing. It's the idea that, yeah, how strong you are and how old you are probably going to be correlated, and those things are probably related to gender, and that's probably related to dementia group. So if I want to talk about what each of these things brings in terms of the prediction that the others do not, to answer that question, they all have to be in the same model fighting it out for shared variance. So unique is the word that would dictate that we don't want separate models with each of these things. We want one model so that they have to provide whatever contribution they each have with cognition that the others do not. What if I change this one word to bivariate? Bivariately. Adjective. Adverb. What does that word mean? That is a word. Bivariate means two, right? Two variables at a time. So if I had a question phrased this way, this would imply separate analyses for each of these things. Like, how do each of these things predict cognition? And in answering questions like that, this might be step one. How does each variable predict cognition? And then how does each variable predict cognition uniquely after controlling for the others? So subtle differences in wording would imply potentially different models here. Now, why am I calling this a main effects model? What's not here yet? There's no interactions. So this is a situation, cough, cough, homework question, where I would describe every single slope as unique marginal. Remember the taxonomy introduced last week? We have bivariate marginal, meaning the slope is just the relation between those two variables, period. There's unique marginal, which is this case, meaning the unique part is after controlling for the other predictors, this is the slope for the unique contribution of this variable, but marginal means not conditional on any particular group. Each of these is the slope for everybody. There's no moderation that's implied by here. So these are additive effects is another way of saying it. And if I want a model implied difference between the non-reference groups, here is the way in which I can get that. Okay, we good so far? Maybe? Good enough? All right, I have the output in both packages so that I can make sure that I hit all the main points, but this is just a repeat of the last model in 4B, which we had talked about already. So we have the fixed effects, we have the model implied difference between the two non-reference groups as well. Here is the same analysis in R. So how successful is my model in predicting cognition? First, good, bad. Let's do a thumbs up, thumbs down. Thumbs up. Model, p-value is 0. We would report that as less than 0.0001, by the way. P is never 0. Here's my effect size for that p-value. About 28% of the variance is explained by these things. That's not bad. Does each of them help uniquely? I don't know that yet. We'll come down here and look at the output. So 29 is the expected level of cognition for somebody who's 85, 9 pounds of grip strength, who's a dude, who's never going to get dementia. That's when all of these things would zero out. From there, each of these slopes describes the unique contribution of that predictor after controlling for other predictors, but the assumption is that these slopes hold for everybody. So for every year older I am than other folks in this sample, my cognition is predicted to be lower by 0.4, period, for everybody. And you can always know if you have to condition on something just by scanning your list of output here. If age is only in one spot, it has to be marginal. Otherwise, if age shows up in more than one spot, it has to be conditional. So each of these is in only one spot. For every additional pound per square inch I can squeeze on my grip strength thingy, my cognition is higher by 0.6. Women are lower by 3.6. And people who are either going to get dementia, who already have it, are lower by 5 or about 16 respectively. Okay. Ta-da. So that's a main effects model. You've seen one before. Note this. Okay, this is me trying to help. Look at this one. Because at this point in the semester, there's no room for subtlety. So 2 interactions. This will provide a lovely template for solving homework spot. I'm going to ask the research question about gender differences. I want to know, do the effects of age and grip strength differ between men and women? So this question requires 2 different interaction terms being added at the same time. So I have my 5 original slopes from the previous model, and now I am adding in an interaction between gender and age, and gender and grip strength. How to add in interaction terms. So for Stata users, if you have an older version of Stata, anytime that your code requires more than one line, you have to tell Stata to keep reading. So you will see this in my code so that it's backwards compatible. These 3 slashes mean tell Stata, I'm not done yet, keep reading. Otherwise, it will get to here and stop. And so your model would only have these things in it. In Stata, interaction terms or quadratic terms as interactions are formed with this hashtag thing here. So you don't have to make the variables in advance. All right, let me see if I can fit the output all on one page here. Almost. Almost. Clicky, clicky. There, got it. Okay, did my model predict cognition? I think so. R square of 0.27, wasn't that about what it was before? It's pretty darn close. So did my interaction terms help? Well, if I come down here, it doesn't look like they did based on the p-value. However, to the extent that these things share commonality, we would want a joint test of both of them, because that would answer the question, is this R square significantly higher than the R square we had without them? So this is an example of when you need another hypothesis test. In Stata, the command is test to do that, so I'm testing these 2 slopes simultaneously to assess how the R square changed as a result of including them. My test statistic, my F, is not significant. Here are my effect sizes. So I computed the difference in R square as semi-partial R square, and the R square increased by 0.002 for these 2 slopes. Not significant. So even though the model as a whole is still significant, like everything in here works together to significantly create a predicted cognition that correlates with the real one, these 2 new terms don't help your cause. But I still want to go through them so that you can get practice interpreting them. Let's see. Let's go down to the R output for a second. And then, actually, let's stick with Stata. Why not? We'll just roll through it in order. That way I don't have to keep scrolling. So in my analysis, let's start with age. And I want you to not pay attention to the p-values. I want you to pay attention to the pattern. I know that you can look at a p-value column and decide if it's less than 0.05. I'm less interested in that. So here's my effective age. It's negative. Who is that the effective age for, given the interaction line?
Someone that's 85 with 9 pounds of grip strength, male, and never gonna get dementia.
Partially right. So you're conditioning on all the other variables to say what this age slope should be, but age only interacts with gender. So if age doesn't interact with grip or dementia, then it's not conditional on those things. It's marginal with respect to those things. It's conditional with respect to this one. So if we work through the process, the main effect slope, so the effect of a predictor by itself, is specific to when any interaction predictors go to 0. So when does this interaction term go to 0? When we're talking about men instead of women as the 0 group. So putting that together, this is the age slope for men, because that's when the other age slope in the model drops out. The other age slope changes by this much in women. So we have minus 0.23 in men. That slope becomes more negative by 0.29 in women, meaning for every unit increase in the moderator. So this is a pattern in which the slope is getting stronger in the one group than the zero group because the signs match, but not significantly so in this case. I can do the same thing for grip strength. Grip only interacts with gender as well. So given that interaction term, who is this the grip strength main effect for? Men again. Yep, good zoomers. So in men, for every additional pound you can squeeze on this thing, your cognition is predicted to be higher by 0.7. Now what happens to that grip strength slope in women, or as the moderator increases here? Which kind is this? More positive, less positive, more negative, or less negative?
Less.
Yeah, this one is less positive is correct for this one. It is positive in men. It is less positive by 0.17 in women. We don't know what it is in women yet, but we know that it's less positive. So is the effect of grip strength stronger or weaker in women, according to this pattern? Weaker. If the signs conflict, it's less something, it's weaker. If the signs are in the same direction, it's more something, it's stronger. Okay, how are we doing, folks? Any of that you want me to hear or say again, or you want to hear differently? Do you want to try and go this way? No. She's like, no, I don't really. But you're going to make me, aren't you?
Yes.
Yeah. At this point in the semester, I usually tell students, I'm okay if you hate me right now. I'm okay with that. Because someday when you have to do this for real and you have resources and you have at least a start point through this class to be able to do it, you'll hate me less. And I'll be okay with that. The other analogy that I give is the Magic Eye posters. Do you know what I'm talking about? Like there's posters or drawings where like this looks like dots, but if you stare at it long enough, then like a 3D image comes out. It's called Magic Eye. That's another way I describe this, is because at first it's like this algorithm is just like, what, but then someday the penny will drop, the 3D image will come out, and then it's like you can't unsee it anymore. Ironically, I'm very good at interaction terms. I can't see the Magic Eye 3D image. I've never been able to see one of those, so I'm only relying on what other people have told me. Question from the Zoomers, thank you. What does it mean that the p-value in the column we were just looking at, showing that in women the relationship is weaker, is not significant? So, great question. This one right here. This p-value is not significant by anyone's standards. So what that means, practically speaking, is that this interaction term would be this large or larger if the true value were 0, like 56% of the time. So well within expected territory, this effect is not significant. What that would mean in practice is I would either talk about how this grip strength slope does not differ significantly from the grip strength slope in women, because that's what this interaction says, but I would still probably describe the pattern. I would say something like, the effect of grip strength is non-significantly less positive in women than in men. And readers will often throw up on less positive as a word, so then you got to start with shallower or things like that that convey the same idea. So I want you folks to get practice with the patterns. That way, when you do have a significant interaction in your life, you're not afraid of it. You're willing to dig in and figure out what it means. And yes, I have helped students decompose 3-way interactions and 4-way interactions before, and they hated every minute of it, but it is possible to do. So this one then, I would say this interaction being non-significant is going to tell us 2 different things. It tells us that the grip strength slope is non-significantly shallower in women than in men. But if I spin the interaction from the opposite direction, it also talks about the gender difference. For this one, though, we have 2 different kinds of conditionality. because gender interacts with two of these other predictors. So the same rule applies. This gender difference is specific to when the interacting variables go to 0. So this happens at age 85 and GRIP 9. So in that subset of people, the gender difference is negative 3.6. What happens to this gender difference in older people? Weaker or stronger? Stronger, more negative. Yep. So the gender gap is probably what I would call this if I were writing about it, because a gender slope is sort of weird. Right now, men have an advantage. That advantage is even larger in older adults. The gender gap widens, is how I would probably phrase that. Likewise, if I wanted to talk about the gender gap as a function of physical strength, that gap also widens as you increase in grip strength. So it's the same pattern, even though it's non-significant for those. So then pieces of information that we would need to ask for separate. Do the two interaction terms work together to improve the model? Sadly, no. What are the effect sizes that go with that? And then how could we get other slopes out of this? So for instance, I have a LINCOM here that is requesting the age slope for men explicitly as what is the age slope plus how does it differ for men. The next one here then gives me what it would be for women. So now I have, these are called simple slopes, or they're called conditional main effects. Here is the age slope in men, here is the age slope in women. The interaction term tells you how these two numbers differ. Likewise, we can do the grip strength slope in men as when the interaction is 0. Here's what it is in women, the linear combination. So now we know that the grip strength slope is significant in both genders, and the difference in those slopes is non-significant. And I have in Stata, it's very easy to get predicted values relative to other packages. So I'm asking for margins, which is predicted means, at dementia being held constant at 0. I am rolling across levels of age. So starting at -5 in increments of 10 up to 5, holding grip strength constant, and then rotating across gender. So I'm trying to show predicted outcomes by age and sex, holding grip constant, and then trying to show predicted outcomes for grip and sex holding age constant. And here are the plots I made. So whenever you have an interaction term that you want to talk about, pictures are going to be super helpful. And you will know that you made your picture correctly if the lines are not parallel. Because what these lines are showing is the focal predictor as the x-axis, so I have age and grip strength as the x-axis, and then different lines for different values of the moderator. So I have men and women here in blue and red respectively. So the negative slope in the left-hand plot shows the effect of age. The difference in this slope shows the interaction with gender. You can also think of this plot as showing gender differences. So the gap here in younger ages is narrower than the gap in older ages. So you can also talk about it that way. And the same is true for grip strength, just heading in the opposite direction.
Can you go back up?
Yeah.
Should that 80 be an 85?
Where
Right
would we?
to the right of your grip and sex.
To the right of my grip pencils. This? Or?
In your red, your
In my red.
label. Sorry, it's a line down from where you are.
This?
Nope.
Oh, this?
Yeah.
Ah, so in this case, I held age constant at -5, which brings it down to 80 instead of
Okay.
85. And I think I had a reason to do that, but I don't know what it is in this moment.
Okay.
I do know that if you want to focus on an interaction term, you hold the rest of the predictors constant at something, and you tell the reader what that something is. The plot would shift up and down if I picked a different level of age, but it wouldn't change, like in this plot, because grip doesn't interact with age, like the slope of the lines will be the same. It's just that they'll be up or down based on where you set age up. You Did you question?
That's what I was gonna ask, I know it's nice to choose your center, but you could choose it at a different location if you wanted to for
Yeah.
any particular reason.
Yeah, it's completely your choice. Now, I will say these are default plots that I got out of Stata. Like, I didn't edit these at all. In practice, I would not show centered age on the x-axis. I would put it back in its original metric. That way your reader doesn't be like, why is it age is -5? Because that's just weird. Also, do you think linear prediction is a good name for a y-axis?
Yes.
The math stat people would say yes, but the rest of us would probably say no. No, this is y hat. Like, that is what that means. Like, this is the result of the linear predictor in the model building and a predicted outcome.
So that one on the left is going from, really the x-axis would be 80 to 90.
It's 80 to 90. Yep,
Okay.
and that is what I would do in practice. Yep, so this is me being lazy for the sake of building a class example quickly, but within this, I believe there is code to do so. I haven't learned to use it, but if you double click in the box where the picture comes up, then you can edit things manually as well. So yeah, I would change this to predicted cognition as the y-axis. Now also, what do you think about the range of this plot? This is 20 to 35, and this is 24 to 34. I'd want to keep them the same at a minimum, but I would also want to scale it such that you're showing a reasonable amount of variability. Like, this scale goes from 0 to 44, so I might make this a little bit wider than what it is. That way it doesn't look like I'm trying to magnify output sort of unfairly. So, also, I would not have like the variable name in here, like sex MW. No, I would just have like men in a blue line and then women in a red line. All right, here's the R output for the same story. So in R, I have added the interaction terms here in colons. I will show you that, I will tell you that if you replace a colon with a star, then what you're changing this to say is give me all of the main effects that are underneath your interaction term at the same time. It can save you typing. But I deliberately do not do that to drive home the point, at least when we're getting started, that you have to have the main effect of age in here before you can add an interaction and have it be an interaction. They have to stay. Even if age is not significant, it has to stay. So colons are adding two-way interactions here.
I'm confused by what you just said.
You're confused, okay. So let me go down to the model. And so age is here, and age is here. It has to be that way. What a lot of folks do is they will add age by gender, for instance, and they'll forget to put this in. So then the interaction term does not mean what you think it means at that point. So the variables that are in the interaction also have to be in the model with fixed effects all by themselves. Is that better?
And so what's the difference with the star? The star is a, like, loop to get around
Yeah.
that?
It's less typing. So let me just do what this would look like real quick to show you. So I could get rid of all of those things if I changed that and that. So then it reads this and it says, she needs age and gender and age by gender. And then it comes over and reads this one. It says she needs grip and gender. Oh wait, we already got gender and grip by gender. So this is a more efficient way of writing syntax, but it requires you to know that you've also asked for the main effects and not forget that part. The same thing is true in Stata, by the way. I deliberately don't show people this, but I'm making an exception. The analog to that is 2 hashtags. 2 hashtags means put in the main effects and the interaction term. It's cool. And what if I wanted a 3-way interaction? Like I could do something like this. Then that would be, I'd have to do 3 of them. But then that would be 3 main effects, 3 two-way interactions, and 1 three-way interaction with just that. It's cool, right? Maybe. It saves typing, but it also is less transparent. So I don't teach that way, but it is possible. Question?
Since you're talking about notations,
Yeah?
would you ever want to do 3 with one and 2 with the other? Like looking at all 3, the connector 3 because 3-way interaction, but it's like a 3 here and a 2 there.
Yeah, it's entirely up to you what patterns of interactions you want to test among your variables. I would say that the only rule is that if you put in something that's higher order, the stuff that is like nested in it has to stay. So if I have a 2-way interaction, each of the variables by itself has to stay as a main effect. If I have a 3-way interaction, then that's each of the 3 by themselves, each set of 2 within the 3, and the 3. So as long as you follow those rules, you're good to go. The rules can be broken in certain cases, but I would not recommend that as a strategy. It will mess you up otherwise. Okay. So in R then, we have our 2 interaction terms. They don't help the model. I found that out by using the function that I built in R squared change F that compares the original model, which is the main effects, to this full model that has 2 interactions. So then I found out the same thing, that my R squared change, or my semi-partial R square, is barely above 0. The 2 slopes do not help, so I would not keep them. In terms of how to get the simple slopes, this is something that you'll get to practice on your next formative assessment. Yay! So this is how I get the age slope for either gender. I go into the equation, I find the things that have age. I come down here, I factor out age, and what's left is how I get the interaction term. So if I just look at these 2, why do I have so freaking many zeros? Why is this so long? This is much longer than what you're used to seeing.
Because there's a bunch of slopes.
Because there's a bunch of slopes. So the order matches this order as it appears in your output. So you have to sort of go through like piece by piece and be like, okay, this is the intercept, I don't need that. This is beta 1. I do need that right here, need one of those. The next is beta 2, 3, 4, 5. Those are all other main effects. I don't need those. Beta 6 is my interaction, and I know that I need to turn that on if it's for women. So I would turn that on here. And beta 7 is the other interaction, so I don't need that in either spot as well. And so then if I come down to the grip one, it's the same pattern. I turn on the main effective grip, which is beta 2. So intercept, first slope, second slope. I turn on the last interaction term if I want the grip strength slope for women. So these can take some practice, but just going through, looking at your code in terms of just what's in the model. So just this much, all the things that have that variable in it have the potential to contribute to your slope. So then here's the 2 sets of results, and I got some confidence intervals and stuff like that. And I made some pictures in R. They're slightly prettier because I plotted by years of age and grip strength, and I labeled the lines separately. I couldn't make the line for men look blue in the legend. I had to give up. It's just going to be a mystery to me. So if anyone wants to solve that problem in my example, be my guest. But then we have, and I also controlled the axes to be a little bit wider. So this is more, better reflecting the range of the outcome variable. And then I have a bunch of white space. All right. And because my interactions were non-significant, I have a very reduced paragraph talking about it. So although the augmented model, do you know this word? That's a GRE word. Augmented means like a model with more stuff in it relative to a baseline model. So although the augmented model accounted for a significant amount of variance, F-test for the model and all 7 slopes, the addition of two interaction terms, so F test for the two, did not help. So, and then what does non-significant mean in practice? The effects of age and grip strength did not vary significantly between men and women. So what we would do traditionally at that point is remove the interaction from the model because it doesn't help. There. How are we doing? That's homework 5. Different variables, but similar setup. Okay, questions, comments?
Can you see how to build the variables in with that box?
How to build variables with what, I'm sorry?
So in the R,
In R, okay.
in the page 5,
Page 5.
that formula. So just another way to build.
You mean the colon versus the star thing?
Yeah.
Okay. So within the formula, this, let me space this out a bit. This and this are equivalent in terms of what it renders. A colon means just that two-way interaction specifically. It implies that you already have separately requested main effects, like separate slopes for each of these two variables by themselves, which I have because it's right here and it's right here. A shorter way to write that is to use a star instead of a colon, and R reads that as, oh, she wants age 85 by itself, gender by itself, and the two-way interaction. So you're asking for 3 things at one shot here. And over here, you would be asking for 3 things, but one of those things is already in the model because you already have a main effect of gender because it would have been put in here. So this will just add what's left, the main effect of grip strength, and then this two-way interaction.
And we have another, I think you just now you said another example like 3 variables.
Oh, if it's a 3-way interaction?
Oh, yeah.
Yeah, we haven't, I was just showing what the code would look like. In that case, like if I had a 3-way interaction like this, I think this would render all the main effects, all the 2-way interactions that are implied within this 3-way interaction and the 3-way.
Okay. So I just write this one and then it can be 3 interactions.
Mhm.
Gotcha.
I'm pretty sure it extends without doing anything else, just with the stars. Yeah, if you want to check that out. So here's why I don't like this as a general thing. I have no idea how to predict what order these things are going to be in the output when they come back. And I need to know that in order to get these right. So I usually prefer longer code that is more transparent because it's like obvious what's going to happen. But if you have a lot of stuff to do and you're at the point where you know what to expect because you've done this type of analysis a lot, then writing less code that's shorter and less prone to error might be better.
Oh, gotcha.
It's just like a coding strategy thing. Okay. Can we do maybe one more model? None of what it follows is needed for homework 5, but this is an example of what it would look like if you have 2 numeric predictors that you want to interact. So I don't know what page I'm on in your handout, 7 or 8, I think, maybe 6, because I've been adding stuff as I type here. So I'm going to remove the 2 interactions that were not significant of gender and age and gender and grip, and I'm going to add a different one. Does the effect of age vary by grip strength, or does the effect of grip strength vary by age? So now beta 6 represents this interaction instead. All right. Let me go down to the R code for this one first. So here's what's going to happen. Let's start there. Here's the story. I have grip strength on the x-axis of this picture. I have different lines for different ages. It looks like, if I just go with the red line, grip strength is positively related to cognition. That's going to be for my reference level of age at 85. What happens if my age is 90? Instead, that's the green line.
More positive.
More positive. What happens if my age is 80? Blue line.
Looks like no change.
Yeah, it's like less positive into 0 territory. So what this pattern appears to be is that grip strength matters in predicting cognition, more so in people who are older. The green line is steeper than the red line is steeper than the blue line. And green is for 80, red is for 85, and blue is for 80. Damn it, let me try again. Green is for 90, red is for 85, blue is for 80. I can also talk about it this way. Now I have age on the x-axis, and I have different lines for different grips. What happens to your cognition as age increases? Bad. Cognition is lower in folks who are older. What happens to that age slope if you are weak? Blue line for grip strength of 6. Really bad. And if you're stronger, green line, slope of, or grip strength of 12, not as bad. So in this case, age is bad for you, more so if you're weak. That's what we're going to find out. But continuous predictors have an extra level of ambiguity to them. Now, why did I pick grip strength 6, 9, and 12? Because that is plus or minus 1 standard deviation and the mean. That's what people do for continuous predictors. Likewise, I picked 80, 85, and 90 because that was most of the range of this variable. But what about age 81? Or age 79? Or grip strength 13? Like, these are all equally valid places to plot something. So I want to show you a technique not next week, the week after that, in 2 weeks, about what we can do to try and think about when these slopes turn on or off at values of the moderator. It's called regions of significance, and it's super cool. But I think that that is a topic that can wait until after. Did you solve your mystery?
The answer is yes. It will list all 3 single, double, and 1 triple.
Okay, so then let me scroll back to that to finish that up. So if I did something like this in R code, that one term would lead to 7 different slopes. 3 main effects, 1 for each of the variables on their own, 1 two-way interaction for each combination of 2 within this, so there's 3 of those, and the 3-way interaction. So that's 7 slopes being requested from this one chunk of code that would have to be written out longhand otherwise. So thank you, Michael, for testing that. I know in Stata it's multiple hashtags is the order of the interaction, and something similar in SAS as well. So that's the next task that we have to talk about, and that's not a lot more of interaction terms from that. Any of that you want to hear again or have me repeat? Okay. Let's walk through the one interaction output then, and we'll look at the rest of the stuff in next time. Just the one. Okay, looking at our output in this case. So has my intercept changed its interpretation? Has it changed who it is for in terms of what the reference group is relative to any of the previous models? You're saying no? I don't think so?
I hope not.
She hopes not. Fair. Other votes? Have we changed what the intercept means in terms of who it's for relative to the previous models? by adding interaction terms or taking them away. We have not. We have not introduced any new predictors into the story. So even though this intercept is a different number than what it was in the previous models because it reflects a different prediction, it's still for an 85-year-old with 9 pounds of grip who's a dude who's not going to get dementia. The main effects are what control what the intercept means. If we go through with the vocabulary lens, in this model, with an age by grip interaction only, is this age slope marginal or conditional? So the vocabulary here, conditional means it's for a specific value of a moderator. Marginal means it's for everybody. So given the age is in here, age has to be conditional. This is the age slope when the interaction term goes to 0, which happens at grip strength of 9. So this is the age slope in people of average strength for this sample. It's negative. Grip strength, marginal or conditional? C for conditional? Same reason. Cough, cough, these are answer choices, cough, cough. How about gender? Marginal or conditional? Marginal. Why? Because gender's not in anything else at this point. This is the gender gap, period, marginally, for everybody. Likewise, dementia, marginal or conditional? Marginal, it's not in here, anyone else. So these are the dementia gaps for everybody, period. So if I go to the age slope, what happens to the age slope as grip strength increases? Good Zoomers.
Less negative.
It's less negative. So if I put the numbers in the story, for every year older you are, cognition is lower by 0.33 when grip strength is 9. That age slope itself becomes less negative by 0.12, the interaction, per pound of grip strength as the moderator. So age has a weaker effect as strength increases. Age ain't nothing but a number. That's what we're hearing. Likewise, grip strength is conditional on age. This is the grip strength slope for 85-year-olds. It's positive. Being strong is good for you. What happens to your grip strength slope as age increases? More positive, more gooder for you. So the benefit of being strong is enhanced at older ages. More gooder for you. So the grip strength slope of 0.6 becomes significantly more positive by 0.12 per pound of grip strength. That's what I would say. We'll do simple slopes next to figure out how we would get predicted slopes at other levels and eventually regions of significance. But I think that can wait. You think that can wait? I think it can wait. You guys have been doing good with the class participation. I want to reward that by letting you go home early.
I won't add a comment.
Yes, comment.
For those who are concrete and new to programming, another reason I like the colon is because there's a colon in R in your code, and then you see a colon matched in your output. See?
That's true.
So that you can see I put it in and there it is.
Yeah, I hadn't even noticed that.
Whereas the star, there's no star down there to match it up.
Yeah, the star implies that line, and that line.
Mm-hmm.
So in your output, it would look the same as that, though?
Yes, it will look like this, even if you didn't
Right.
write it that way.
Okay.
Uh-huh.
And it'll reorder it in terms of how it wants it done, that you didn't control.
Oh,
Yeah, fun. And I spent like 2 hours one day trying to see if I could change the order, and I gave up. I'm just going to have to live with this. So. All right, then. Let's see. You will have a formative assessment due after break. I will put that up later this week along with homework 5. And I'll let you know when the next one's ready, and we're getting it done.
And we are not meeting on Thursday?
We are not meeting on Thursday. There is no class on Thursday, but we do have office hours the rest of this week as usual.
So the formative assessment is due the Monday we come back.
Monday after break. Yep, not next Monday. I intended it for it to be like a review/refresher before we all show up again. So you can get your brain back into the class on the Monday we come back. That's my thoughts. Or ahead of time if you wish. All right, thanks for being here. Have a good break. Take care of yourselves, and I hope to see you in a few weeks. Bye for now.